Alrighty. So, welcome to our last lecture. You made it. I'm going to move some things around here because I'm having to use an external mouse because yesterday my laptop decided it didn't want to work with the trackpad anymore, and that's okay. There we go. All right. So today I want to do a few things. I want to talk to you guys a little bit more about the final and make sure we're all comfy with how the final is going to go and how grading is going to work and all of that good stuff. And then we need to talk about systems of inequalities. That's our last little topic for the class. So give me just 1 second to get things buttoned up here. I'm going to close my office door. So switch over to the doccam. Alrighty. So first things first, exam 4, which is the take home. I will post to Canvas right after class. This is our last midterm exam. Usually we would do it in class. But in order to kind of make things a little bit easier on you guys, instead of having this be a proctored exam like we did on our lock for exam 3 in my math lab, I wanted you to be able to work it at your own pace and not stress too much so you can focus on preparing for the final. So it's going to just be this little take home that we've been talking about. And it's just going to cover chapter 6, just systems of equations and systems of inequalities. Fairly straightforward stuff. You can either print it, the PDF I will send you, and write directly on that. Or you can just write your solutions on your own blank paper. Whatever you do, you need to upload the PDF scans of your worked exam no later than 11:59 on the 28th, which is the day of the final. Okay, so it just covers chapter 6. It just covers the last 2 homeworks, the things we've been talking about this week, and I guess the last day of last week. I don't think you'll have a very hard time of it. It is usually a very high scoring exam. Please make sure it is your own work, so you can use your notes. In your book, but nothing else. In particular, please, no internet, don't Google things. You can tell when you pull shit down from the internet, and no help from other humans. Whether they're people in your family or people from the class or anything else, please just don't do that. Yeah, make sure that your work is your own work on these tests, especially on the take-home test here and on the final. So that's exam 4. Any questions about exam 4? About the take home, how it's going to work, what I'm expecting of you, what you need to do? Fairly straightforward, right? So if you do run into any questions, if you are tempted to Google, or if you are tempted to ask a classmate or a family member, write me a Canvas message instead, right? Think of it just the same way as we would do an in-class test. If you had a question and you were like dead stuck, you can raise your hand and I'll come by and give you a little nudge. If you send me a little Canvas message saying, hey, I'm not 100% sure what to do with this problem, or I'm not sure if I'm doing this right, I can give you like a little bit of encouragement if you're doing it right, or I can give you a little nudge in the right direction if you're making a mistake, and I'm happy to do that. I would much rather do that than deal with any sort of academic misconduct issues. So please, if you find yourself in that situation, please go ahead and send me a Canvas message, and I'll help you out a little bit. The final exam, which again is on the 28th, and it has to be during this time from 10:30 to 12:30. So that's from 10:30 a.m. to 30 minutes after 12 noon. Will be online. Run exactly the same way. Exam 3. So that means you're going to go to Canvas, you're going to click on Honor Lock. At 10:30, the Honor Lock page will have something titled Final Exam appear. Yes, you have to take the final. The final is worth 25% of your grade. If you do not take the final, then even if you have 100% on everything in the class so far, your grade will go down to a 75. The final is not optional, not at all. It is a cumulative final. It is like the main benchmark in this class. So it's 10:30 to 12:30 on the 28th. It will replace your lowest exam score. So if you had a midterm exam on which you did not have a stellar score, like maybe exam 2 was just a total bomb for you, like that polynomial or power function stuff just didn't click back then, and you got a bad score on exam 2, if you do better on the final, then the final will replace that score. So if you got like a 40 on exam 2 and you get a 75 on the final, then that 75 is going to go back and replace your exam 2 score. But it doesn't work the other way. It's just the final replacing a lower scoring exam. Other exams do not replace the final. So read the syllabus, right? The syllabus is still what it is. The only thing that has changed with this coronavirus bullshit from the syllabus is that the final now replaces the lowest scoring exam, if that helps you. Let's see. So please read the Canvas announcement I posted. About the final. I really do need you guys to write down all the work for every problem you go through, even if it's just a tiny little bit of work, even if it's just 1 line or 2 lines of little algebra or arithmetic or logic, whatever it is that your process gets you from the question to the answer you submit, I need you to write that down and scan that shit back to me in Canvas immediately after the test. I have to be pretty brutal about this. I don't really have a choice here. If I don't receive those things, if I don't receive that material right away after you finish the test, then I'm forced to assume that there's a reason for that. And the only logical reason there would be that the work you did to get to your answers was not your own work. So for the purposes of academic integrity, I absolutely need you to write out your solutions and scan them into Canvas immediately after you finish the test. And I talk about this at length in the Canvas announcement about the final. So if you haven't read that yet, please, after class, navigate over to Canvas and read the 2 announcements that I posted yesterday. So that's that. There will be a large review session, a large Zoom-based review for a final on Sunday. So every semester I do one of these for the college, where I get, you know, all the people together who want to have a big review. Usually we do it in P260, and it's always Sunday 5 to 7, the Sunday before the final. And so we'll be doing the same thing this semester. It's just, instead of doing it in person and P260, we're going to do it in Zoom. I'll post a link to the Canvas announcements. You'll find it the same place you find the links to our regular class meetings. And you can bring any questions you want there. You can bring questions from homework, questions from quizzes, questions from past exams. I would encourage you to also look over the department's exam review packet. So Santa Fe has a packet online called Study Questions for the Common College Algebra Final. I think I have a copy of it open here, yeah. So if you just Google search Santa Fe College Algebra Study Questions for Final, you'll find this, but I can paste it into the chat here also right now. Yeah, here we go. So that thing I just pasted into the chat, that is the review. That is a link to the review for the final exam. I also think, I was looking around in MML yesterday, it looks like our course coordinator opened up a review. I'm not sure if she intends for you guys to be able to see that yet or not. If she does, then she will unlock it. But look in MML for a final exam review also. I think she may just be experimenting with that. It might not be open to you guys. But if you see it there, by all means, play around with that. And either way, I strongly encourage you to look at that packet, the study questions for MAC1105 Common Final that I pasted a link to in the chat there. That would be a good source of questions to talk about during our review session on Sunday. It would also be a good source of just problems for you to practice, as would be the homework and the quizzes and stuff. So I am going to go back into MML and unlock just all the homeworks, just everything from the beginning of the semester. So if you want to go in and work to improve your grade, you can. If you want to go in and just get more practice on something, you can. I don't see any harm in doing that, so I will just go ahead and do that. That's a good question. Will there be a recording of the review for the final exam on Sunday? I don't see why not. Yeah, I have my Zoom settings to automatically record all these meetings. The only reason there wouldn't be is if I ran out of hard drive space on my computer, which is definitely a possibility. But yeah, no, I don't intend to turn the recording feature off, and I could upload that review video to YouTube. But it's not going to be anywhere near as useful as you coming to the review where you can ask questions. Specifically coming to the review and bringing problems that you want to see worked and ask questions about is the best thing you can do for yourself to get ready for the final. It's good questions, good comments. What else are we thinking? If you look in the Canvas announcements, you'll see one other announcement from yesterday about the exam 3 grades. So the way I set up the MyMathLab gradebook at the beginning of the semester is there's a slot for each of the tests in the gradebook. And one of them, so the tests are all usually offline. They're all usually paper tests. And the gradebook is set up to weight things and manage the grades according to the syllabus. So in order to make things easy, what I did is I copy and pasted all of your scores from exam 3 that you took online into the test 3 slot in the gradebook. Which means that they are now in there with the appropriate weight. So the grades in MyMathLab are more or less up to date. That grade is your grade right now, the grade you see in the MML gradebook. if you did a makeup test or handed something in late, I am still getting around to that shit. I know it sucks. I know that there's like 2 or 3 people who took the exam 2 like in office hours just before the coronavirus stuff happened. And I haven't gotten to those yet, but I promise you I'm going to get to those just as soon as I can. I'm working on it. My goal is to have the gradebook completely up to date by Sunday. If you do have any questions about your grade or what you should be doing in the course regarding the SU option or staying in the course, or you're just nervous about your grade and you want to talk, please send me a Canvas message and we can talk about that stuff. The activity grades are going to be a little bit complicated. So any activities that we actually did in class, I will be grading and getting into the grade book. They're a very small portion of the grade, so don't stress about them. And then anything else I will be omitting. I think we got through like activity 3 or something like that in class. I don't actually remember off the top of my head, but yeah, any of the actual physical activities we did in class, I will get those graded and into the grade book by Sunday. Anything after that is just going to be wiped. It's not going to hurt or help you. It's just going to be omitted from the grade calculation altogether. How many questions are there on the final? I reviewed the final the other day as it is in its current state, and I'm not sure if it's been updated since then, but I think there were about 15 like multiple choice and about 15 free response for a total of around 30 questions. So you have about 2 hours to answer about 30 questions. And as you guys saw, those go really quick, right, on MML. The average time actually spent taking exam 3 on MML was around 20 minutes, even though that was a 16-question exam. The important thing, the most important thing for the final is that you are able to get in and you're able to take the test, which means you need to follow the instructions for honor lock very, very carefully. Second most important thing is the academic integrity stuff. So make sure you're writing down your solutions as you go, and make sure you upload them immediately after the test. I don't want them hours later. I definitely don't want them days later. I want them like minutes after you finish the test. That way I can be confident that the work I see there is the work you use to get the answers that you put into MML. Project 3. No, Project 3 was not omitted. Project 3 was the project that we sent out before exam 3. If you haven't handed that in yet, I will still take that. You can submit it in Canvas. So the same way that you submitted your scratch work in Canvas for exam 3, you were supposed to submit the project on that day. If you haven't done that, that was the one on exponentials and logs. I was helping some folks just yesterday, still finishing that up. If you haven't done that, that's okay. It's not the end of the world. But please get your solutions scanned and uploaded to Canvas. Yes, John, I did see your email, but I have not been able to read it yet. So I saw that it was there in the inbox, but I haven't actually opened it and taken a look at it yet. So I will reply to that a little later today. Any other questions or comments about this procedure stuff, grades, exams, that sort of thing? All right, so look for the Canvas announcement with the take home. That will show up after class. Remember, it's due on the day of the final at midnight. So if you want to emphasize studying for the final between now and then work the take home afterwards, that's okay. There's time built in for you to do that. But you will need to scan and upload your solutions for exam 4, the take home, no later than 11:59 on the day of the final. And if you want help on it, if you're stuck on something, please don't Google or cheat. Just send me a message and I'll help you out a little bit. I'll give you a nudge. I don't think you'll find it hard at all. The final exam is on the 28th, and it has to be from 10:30 to 12:30. If you have a conflict, if you have some other exam that is for whatever reason scheduled during that time, let me know immediately, and we will get it fixed. I think the only possible conflict is people who are enrolled in Core Bio 1, BSc 2010, BSc 2010. Occasionally, the Natural Science Department runs their final for BSc 2010 at the same time as our final. And we do have contingency plans in place for that. But let me know right away if there are any conflicts there. check out the Canvas announcement on the final. Make sure that you're ready to do all the things that you need to do. And we'll make sure everything goes smoothly. So Katie, if you're having a hard time finding where to submit project 3, it's under the Canvas assignments. If you want to email me the PDF, that's okay too. It's not a big problem. We do have one last topic to cover before we try to find a clean-ish sheet of paper before we finish up the mathematics for the term. We've talked about systems of equations, but we haven't talked about systems of inequalities, and that is what your last homework is on. So a system of inequalities is what it sounds like. It's a collection of inequalities meant to be solved simultaneously. So just like a system of equations is a collection of equations meant to be solved simultaneously, system of inequalities is a collection of inequalities meant to be solved simultaneously. Tyler, exam 4 is a take-home that I will be posting to Canvas today, right after class. I will post a Canvas announcement with a link to the PDF for the take-home. You will need to download that PDF and either print it and solve the questions on those sheets and then scan and upload them, or download the PDF, solve the questions on your own paper, and then scan and upload those. So if you rewatch this video, I'll be posting the recording for this video a little bit later today. I talked quite a bit at the start of class about both exam 4 and the final, and so make sure you do that. Make sure you rewatch the video from the start once it's up. But yeah, it's a take-home. You'll find it on Canvas later today, and it is due at 11:59 on the 28th, which is the day of the final exam. So in order to talk about a system of inequalities, we need to be comfortable with just regular inequalities. And we've looked at inequalities in one variable, but we've never really looked at inequalities that have two variables. So I want to do a quick review of linear inequalities in two variables. For example, y is less than or equal to 2x plus 1. This is a linear inequality with two variables. X and y are the variables, and it's linear because both of the variables are showing up upstairs and to the power of 1. Right? So if it was an equation, it would be a linear equation, but it's an inequality. So it's a linear inequality. The solutions to the linear equation y equals 2x plus 1 are all the points on the line y equals 2x plus 1. So that's a line with slope 2 and y-intercept 1. It looks like this. This is the line y equals 2x plus 1. So along this line, every point satisfies this equation, which means it automatically satisfies this inequality because this is a less than or equal to inequality. But the way we solve these is first you graph the related equation. 2, then you identify the regions the graph partitions the plane or splits the plane into. So over here I have a region, maybe I call this region 1. And over here I have a region, maybe I call this region 2. Right? One is like above the line, one is like below the line. Then your third step is to identify or determine which region solves the inequality. And there's two ways to do that. You can kind of think about it geometrically. Like here, if I want to say y is less than or equal to 2x plus 1, this line is all of the points where y is equal to 2x plus 1. So the stuff that's below this line will be the points where y is less than or equal to 2x plus 1. Or you can test points. So either think about above corresponding to y is greater than or equal to da da da, and below as corresponding to, here, let's do this, and below corresponding to y is less than da da da, or test a point from each region. So the main idea is that either every point in region 1 solves the inequality, or no point in region 1 solves the inequality. So if you find one point up here that works, that means every point up here works. If you find a point up here that doesn't work, that means no points up there work. Similarly, if you find a point down here that solves the inequality, that means every single point in region 2 solves the inequality. And if you find a point in region 2 that doesn't solve the inequality, that means that no points in region 2 solve the inequality. So here I could say, using the above-below logic, this says y is less than or equal to 2x plus 1. That means I'm looking for all of the points x comma y that are below the line. So I know region 2 is going to be the solution region. But if I wasn't certain, if the geometry wasn't clear, if it was hard to say what's above or what's below, or for whatever reason I was insecure about that result, I could test a point. So from region 1, I can test, I need to make sure I'm grabbing a point that is from this region. This x-intercept here is -1/2. So I could test like -1, 0. And when I plug -1 in for x and 0 in for y, what I get is 0 is less than or equal to 2 times -1 plus 1, which is the same as saying 0 is less than or equal to -1, which is false. So region 1 does not solve the inequality. It is not a part of my solution. Right? So if I plug in the point -1, 0, which is a point in region 1, then I get a false statement, which means that region 1 is not a part of my solution set. From region 2, region 2 contains the origin, right? So here's the test point I used in region 1, -1, 0. Here's the test point I'll use in region 2, 0, 0. So in region 2, I'll test 0, 0. Plugging in 0 for y and 0 for x, I get 0 is less than or equal to 2 times 0 plus 1, which is the same as saying 0 is less than or equal to 1, which is true. Hence, region 2 is a part of the solution. And since there's only those two regions, region 1 and region 2, region 1 is not a part of the solution, region 2 is a part of the solution, I can come back and say my whole solution has to be region 2. And the way I indicate that is by shading. All right, so I would shade that portion of the plane and say this is the solution to that inequality. This is just one linear inequality. A system of linear inequalities means doing this twice. And then the solution to the system is the overlap. It's the stuff that solves the first inequality and also solves the second inequality. Just like a system of equations is going to be a point that solves the first equation and solves the second equation. The solution to a system of inequalities is the region that solves the first inequality and also solves the second inequality. So you'll do this twice, and then you'll take the overlapping shaded region. There's one little subtlety, and that's what to do if you have a strictly less than inequality rather than a less than or equal to. So here I have a less than or equal to, and the points where y is equal to 2x plus 1, that's my line. That's the line I drew right here. These are all the points x comma y where y is equal to 2x plus 1. And I drew that solid because I know that the points on that line do satisfy this inequality. If it was a strictly less than, then I would draw that line in as a dashed line to indicate that the points on the line are not a part of the solution region. So let's look at a linear system, a system of linear inequalities, and let's have it involve at least one strict inequality. So let's solve the system of inequalities y is greater than, how about x minus 2, and y is less than or equal to x plus 1. Actually, let me change this to a negative x plus 1. Yeah, let's do it like that. So I'm going to graph both of those related equations. So the related equation for the first inequality is y equals x minus 2. So I'm going to graph the line y equals x minus 2, but I'm going to do so with a dotted line because this is a strictly greater than, not a greater than or equal to. X minus 2 has a slope of 1 and a y-intercept of negative 2. So that line looks like this. And I'm drawing the dotted line or the dashed line instead of a solid line because the inequality there is strictly greater than, right? It's not a greater than or equal to. So this is 1, this is 2, this is negative 1, this is negative 2. And then the line associated with the second inequality is y is less than or equal to, so I'll draw this with a solid line, negative x plus 1. So that's a line with slope negative 1 and y-intercept positive 1. So he looks like this. All right. And this is the equation, this is the graph of the equation y equals negative x plus 1. And what you see is that this divides the plane up into 4 regions now. Each line chops into 2. That's the x-axis, this is the y-axis. So I've got 2 choices as to how to proceed. I could label each of these regions like 1, 2, 3, and 4, and I could test a point from each of those. Or I can use the above-below logic. The first inequality says y is greater than x minus 2. So I'm looking for all the points x comma y where y is bigger than x minus 2. This line is all of the points where y is equal to x minus 2. So the places where y is bigger are the places that have bigger y values. It's the stuff above. So the solution to that first inequality is all the stuff above that line. Right? Now the second inequality says y is less than or equal to negative x plus 1. So using the above-below logic, the solution to the second inequality, can I help you, Noah? Sorry, my cat's pawing at the door. Come on in, big kitty. Solution to the second inequality will be all the points below that solid line. So the solution to the second inequality is all of this stuff. Which means the solution to the system is the overlap. It's the stuff that's solving both the first inequality and the second inequality at the same time. So the solution to the system is this stuff. Right? Any ordered pair that's in this twice shaded region, the region that's shaded by the first inequality and also by the second inequality, that's the stuff that solves the system. So you take any ordered pair from that doubly shaded region and it will solve both inequalities, which means it solves the system. The collection of all such points is the solution set to the system. And the way we describe these is always just as I've done here. You graph them, right? You graph them. In MML, I think they'll have you graph both lines, one dotted, one solid, depending on the inequality types here. Maybe both dotted, maybe both solid. It just depends on what you're given. And then they'll let you shade the solution region to one inequality with one color and shade the solution to the other inequality with the other color. And then the overlapping region is your solution for the whole system. We could have also gotten here with test points, right? I could label this as region 1, 2, 3, 4. And if I test a point from region 1, like 0, 0, you'll see that this is a true statement. Here you get 0 is greater than negative 2. Here you get 0 is less than or equal to 1. That's true. And if you test a point from each of these other regions, you'll see that either one or both inequalities is not satisfied. Any questions on what we did here? How we arrived at that region as our solution? How am I doing on time? Okay, we got a little bit of time left, and in the time we have left, I want to look at one nonlinear system of inequalities. Let's look at y is greater than or equal to x squared, and also y is less than 1. Let's do 1 minus x. Keep it exciting. Okay. This is a nonlinear system of inequalities, but we solve it the same way we solve a linear system of inequalities. So for equations, we have different methods for different situations. If it's linear, we use the elimination method. If it's nonlinear, we use the substitution method. But for systems of inequalities, we just graph. Right? We always just solve using the graphs. So I'm going to graph the corresponding equations. The corresponding equation for that first guy is y equals x squared. And we know what that looks like. Y equals x squared is a parabola. Looking like this. And y equals 1 minus x, that's a line with slope -1 and y-intercept +1. So he looks something like this. And I'm going to draw him in as a dotted line. I should get rid of this label because it's going to be confusing there. Because this is a strictly less than inequality, not a less than or equal to inequality. Okay, so this guy is y equals x squared. This guy is y equals 1 minus x. And again, you see this splits the plane up into several regions, right? You've got the region that's below both, below the line and below the parabola, that's down here. You've got the region in here, that's above the parabola but below the line. You've got this region, if I draw this up more, there's a region out here that is below the parabola and above the line. And that's the same as this region over here, which is below the parabola and above the line. But you could say that you have 1, 2, 3, 4, 5 regions all together. Really, the region out here and the region out here are the same. But what I want to do is find the region that solves both inequalities. So if you look at that first inequality, y is greater than or equal to x squared, that's everything above this parabola. And the second one says y is less than 1 minus x. That's everything below this dotted line. So the stuff that solves both is this little region in here, right? This stuff. This is the stuff that is in both regions. The points on that line, the points on the dotted line, are not a part of the solution set. The points on the parabola in here are a part of the solution set because they are both below the line and on or above the parabola. So the region that I've just traced over with pencil, this is your solution set. Okay. Questions about either of these last two examples? So I don't think you'll find this systems homeworks difficult. I don't think you'll find exam 4 all that difficult. Just take the time to practice. If you do have any trouble with any of these, just rewatch the videos, right? We've spent a few days now solving systems. We talked about solving linear systems using substitution and elimination. It's important that you learn how to use elimination, and there are problems on the take-home that say solve this system using elimination. On those problems, you must use that method. If you solve those by substitution, I'll have to take points off. Solving systems of inequalities, I think, is in a sense easier than solving systems of equations, because rather than having any like algebraic procedure, we really just need to draw the graphs. and then determine which portion. Let's see. If I don't specify the method, you can do whatever you want. Yeah, solving by graphing, though, is not really a solution method. I mean, you can guess like that, but it's still just a guess. Zach wanted to see the bottom portion of the first page. You mean this guy, where we talked about the tests? But yeah, if I don't specify a region, you're welcome to use whatever method, or I don't specify a method, you're welcome to use whatever method you like. So Zach, were you asking for this or for this? First problem. All right. That was this guy, right? Oh yeah, sure. Here, let me find that. Here we go. So this is where we were solving using test points rather than thinking about what's above and what's below. John asked if we're going to have class on Monday. No, we don't. This is our last class. This is our very last class. So I will have that review session on Sunday from 5 to 7. And then I will also, I'll have my regular office hours next week on Tuesday and Thursday. But if you need to talk to me or you want to talk to me or want to work problems, just send me a Canvas message and we can always set up a separate meeting. But yeah, no class on Monday. This is our last class. Well, yeah, so Manuel just asked, is it possible to solve systems of inequalities by graphing? Oh, without graphing? Not really. The nicest way to describe the solution set to the systems of inequalities we are going to look at is as the solution set to the systems of inequalities we are looking at. So no, not really. There's no like algebra process for solving these, because we need a way of describing ordered pairs and describing like this set of ordered pairs. Nicest way to do that is just by saying it's the solution to that system of inequalities. So not really. Some systems, yes, but there's no general method. No general method besides graphing and shading. Exam 4 is being given out today. It's a take home and it is due on the day of the final. So it'll be due, I will accept it all the way through midnight on the 28th. So I will post it to Canvas just a few minutes after we finish class here, and then you will have to submit your answers, your worked out solutions on Canvas by midnight on the 28th. How many questions on the take home? I don't even remember. Not too many, like 15 or something like that. So it's about like one of our normal tests. The final has about 30 questions, I think. It might be revised since I saw it last, but the last version of the final I saw had 15 multiple choice and 15 free response. Okay, is there anything else from these notes here or any other questions? It has been a really weird semester, yeah. So thank you guys so much for hanging in. I'm really, really proud of y'all for sticking this out. I know it hasn't been easy for anybody. Please make sure you follow the directions for the final exam exactly. It's very important that the honor lock stuff goes smoothly there. I don't see a name there. So that last question, who is that coming from? 03006, who is that? Brittany, no, so, oh, yeah. So I talked about this at the beginning of class. I moved the exam 3 scores into the test 3 spot in the gradebook, right? So the way I set up the My Math Lab gradebook at the beginning of the semester for me to do paper tests and put your scores in the test 1, test 2, test 3, test 4 slots. And instead of reforming the gradebook to include the exam 3 assignment and wipe out the test assignments, I just took the scores from your exam 3 and copy pasted them into the test 3 slot in the gradebook. So what you see in test 3 in the MML gradebook is your score on exam 3. I haven't finished reviewing the work for those. So there are some questions there where, if you did most of the work correctly, but you typed in the wrong answer, you may be entitled to some partial credit. Take a look at the announcement I posted yesterday to Canvas on the exam 3 grading. I think it's titled exam 3 grade info. Take a look at that announcement. I explain there exactly what I did and exactly what you can expect. If you don't see anything for either, if you don't see anything for test 3 in the gradebook, that means something is wrong. So that should not be the case. I do remember looking at your stuff and moving it over. So if you're not seeing something, that's a glitch on the Pearson side that we need to resolve immediately. But take a look under test 3. You should see that score there. Any other questions or comments before we wrap it up, guys? Anything else we're curious about or nervous about? I know that there are still some paper assignments that we did just before the coronavirus madness got started that I haven't scored yet. Remember, my goal is to get the MML gradebook completely up to date by Sunday, so we can know exactly where we stand moving into the final. Final is 10:30 through 12:30. So 10:30 a.m. through 30 minutes after 12 noon on Tuesday, the 28th. All right, and you're going to access it. It's going to be exactly the same as you got into exam 3. So you're going to go to Canvas, you're going to go to Honor Lock. At 10:30, an Honor Lock assignment will open titled Final Exam. You will click Launch Proctoring, and you will get into it the same way. So it's important the Honor Lock stuff is working. If you did have trouble with Honor Lock before, please go back through that practice quiz and make sure that shit is working. It's so important. Last time we did the Honor Lock test, I got something like 130 emails in the space of 2 hours trying to put out all of those fires. If we do it like that for the final, shit's gonna be bad, right? Because the final, I can't do a makeup for, I can't wiggle times around. There's really very little flexibility. So it's important that everybody is ready to go with Honor Lock for the final. So please test it out. If you have been having webcam issues, try to fix them. If your webcam has been like glitchy or broken, you don't have one, try to borrow one or grab one. If there's any sort of problem like that, I need to know immediately. If you have any testing accommodations through the DRC or anything else, please contact me about that and we will try to get a workaround built in for you there. I've been told that the college is working on something, but it's not something I have direct control over. It is, however, something I can like lean on them to make sure they're actually doing their shit. But yeah, 10:30 to 12:30 is the scheduled time for the final on the 28th. Alrighty. Okay. So if you do have other questions, reach out to me through Canvas messaging and I'll do my best to get back to you quickly. It is that busy time of the semester, so a bunch of shit is piling up and it might take me a little bit to reply. If you don't get a reply quick or you're getting nervous or you think maybe I forgot or something got lost, just message me again. but no more than 2 in a 24-hour period, right? Like if you need to talk to me about something, I don't get back to you right away, you can hit me again, but then give me a little bit of time to respond. And then on Sunday, we'll have that big review session. So anybody who wants to come in and ask other questions or talk a little bit more is welcome to do so. Make sure you go to Canvas, download the take-home test, get that done and submit it on Canvas before midnight on the day of the final. And if you want to review any material, you can go back over the old homeworks, the old tests. I'm going to pop open everything in MML. It will all be open to play with. And also be aware of the final exam review packet. If you scroll all the way up in the chat to the very top of the chat, there's a link that I posted at 11:13 a.m. that takes you to the review packet for the final exam. Everybody comfy? Any last minute questions? Okay then, so I'll see you guys on Sunday at the review. If you need to get a hold of me, of course, Canvas message, be a little bit patient, but if you get nervous that you're not getting a reply quick enough, feel free to nudge. Yeah, I'll see you Sunday. Good luck on the final. Remember to turn in the last few things, and I hope you guys have a wonderful rest of your day.